This is an Atwood machine problem, right? We've done Atwood machines before when we talked about forces, but those were easy because we didn't care about the mass of the pulley. Now we care about the mass of the pulley, right? So this pulley, if I let's say M3 is greater than M4, and M4 goes up and M3 goes down, these two pulleys spinning are going to have a moment of inertia, and there's going to be a torque required to spin them. So it makes solving them a little more complicated. But if you follow the same process that we did, if you write equations for force or torque, then all we do is write the equations out and then combine them. Okay, so let's start by doing that. Let's start by writing an equation for the left pulley and for the right pulley, right? Okay, so, well, first let's start off with moment of inertia. So for each pulley, I is going to equal mr squared. That's going to be the moment of inertia of each pulley. So I can say, right, the net torque is going to be I times alpha. Force is mass times acceleration. Torque is moment of inertia times angular acceleration, right? Same concept. And that's going to equal I is mr squared, right? So I'm going to say mr squared times my acceleration, my angular acceleration, which I know is linear acceleration divided by r. Okay? So if right, because I'm converting angular to linear. So same thing. So if I simplify this, basically net torque, see that square, and that cancels out. So it's just m times r times a. Okay, so now I have that. Okay, so let's do the left pulley, right? So for my left pulley, that's this one. When left wheel has a mass of 2.4, raise right wheel. Hanging mass on left is 1.91, right's 1.68. So this is the heavy one. So this thing is going to accelerate that way, right? So this wheel is going to turn that way, and this wheel is going to turn that way. And then this one is going to accelerate up. So let's do an equation for my left pulley. Net torque equals MRA, right? That's the point of doing this. M times R times A. Well, I'll call it M1, right? Because it's M1 times R1 times A. And that's going to equal to the tension in rope 1 times R1 minus the tension 2 times R1. Right, so this rope is pulling down that way, this rope is pulling back on it, right? Even though it looks like it's going forward, that rope is applying a force this way, and this rope's applying a force that way. Excuse me. But this one's bigger, right? So T1 times R1 minus T2 times R2. Okay. And so then, no, look at that. So these R1s all cancel out, right? So basically I have M1A equals T1 minus T2. All right, so there's one equation. And now I'm going to do the right pulley. So same concept. I'm going to write out the right pulley. Okay, so I've got two equations, right? I did one for the left pulley, one for the right pulley. Now let's go do Newton's laws to these two blocks, right? So let's do M3. So M3 has T1 pulling up on it and the weight pulling down, which is M3 times G. So let's write an equation for this one. So net force equals mass times acceleration. Right now I'm not talking about rotating things anymore. I'm talking about linear stuff. So I'm going to use the regular Newton's second law. Net force is mass times acceleration. So that's M3A equals M3G, which is pulling down, minus T1 pulling up, right? So this one is bigger than that one. So that was first, subtract that one. So there's an equation. And then let's do M4. So M4 is going to be the same thing. So same thing. It's accelerating. So mass 4 times the acceleration equals T3 pulling up minus M4G pulling down the weight. So I've got 4 equations now. If I take these four equations, right, so here's one, here's one, here's one, here's one. I should say it's just that part, right? If I take these four equations and I add these four equations up, you get something that looks like this. You get, right? I get this big equation, M1A plus M2A plus M3A plus M4A equals M3G, the weight of M3, minus M4G, the weight of M4. And so if I take these, right, I can distribute out the A. I'm going to leave this to you, right? So take this equation. You can pull the A out because all of these terms have an A. So I can be left with A times something equals M3G minus M4G. And then you can solve for A, right? So once you've gotten to this point, it's just a matter of solving for A.